Hello, hello everybody. A huge welcome to our webinar. We're really excited to have you with us. Just a few housekeeping rules. As Jack and Joel both go through their presentations today, as this is a joint webinar from both DNV and from Eigen, if you've got any questions at all, please do pop them into the chat or you can raise your hand. We will be keeping some time aside at the end of the presentations to go through your questions. And this is obviously being recorded as well. So should you need to hop out, we'll be circulating the replay afterwards as well. All right. So what I'm going to do is I've put everybody who's now attending on mute. I'll keep an eye on anyone who's coming in and I'll hand over to Jack and Joel to kick off this presentation. Thank you so much.
Okay, good morning everyone. Hopefully you can see my slide now. So thank you for joining. As Effie says, we're very excited to be talking to you today. I'm very excited about this collaboration between ourselves and DNV and with Eigen, which the topic is connected next-gen verification. So I'm going to start off by doing a short introduction, and then I'm going to go a little bit of background as to what verification is, for those of you not oil and gas or not in this kind of regime. And then we'll talk a bit about what next-gen is today, what the benefits are, and perhaps what are some of the limitations. And then Joel will take us forward there on how we can improve on that by this collaboration with Eigen. So very quickly, yeah, as I said, my name is Jack Downey. I'm responsible for development and innovation in the UK Energy Systems division within the UK, in what we call assurance services, and I'm the project manager for next gen verification. Joel, do you want to do your own introduction?
Yeah, sure. Yeah, Joel Chacon. I'm Chief Commercial Officer for Eigen, but I'm still, deeply involved with customer engagement and conceptualization of new projects. Thank you.
Thank you. Okay, so as I said, a bit of background. What is verification? What's it about? So this is required by law in the UK under our safety case regulations. And just very quickly over this, from the safety case regulations, you have to identify what your hazards are offshore. And from there, that defines what your safety and environmentally critical elements are. And that forms the basis for everything that we as a verifier do. You need to define performance standards and clear criteria against which you will measure the status and the compliance, I suppose. What are your compliance goals for each of the safety and environmentally critical elements? And we will then have a verification scheme, which during operations is what we use to measure whether or not you continue to be compliant with the goals that you set out. So we have different steps along the way where we review on the list of the SECIs and a review on the scheme, but really what we're talking about here is the examination piece and techniques to use to assess the overall compliance. And just as a very brief kind of example list, these are the sort of things which are considered to be safety and environmentally critical elements for offshore operation. I'm not going to read them. You can have a quick look at them yourself, but it's in general, it's the integrity and the safety systems. So the benefits of today's approach and how we do it, I mean, it's been in law for over 25 years now, and there's no doubt that we're compliant with the legislation. It's well understood, well executed, and we comply with what the letter of the law says. It provides an independent and competent overview of how operations are running. And there's a lot of experience on both sides in terms of those that provide the independent verifier role and those receiving it, who are the duty holders, the guy that operates the offshore platform. And it provides a very clear and a very sound framework for managing risk. But on the other side, we're still having incidents and accidents, hydrocarbon releases, and the regulator, who are the HSE government department, they still go offshore and they still find things that we as a verifier don't find. So why is that, and what should we be doing differently? And studies will still show today that these relatively minor incidents these days, there hasn't been a major accident in the UK for, well, more than 30 years, but when they are having incidents, then they reveal that often it's the people in process parts rather than the plant is causing the issue, and how does that apply to the barrier model? And what we do today is still a little bit like your car MOT, is that it was okay on the day that we were there. If the independent verifier goes offshore, he tests the system, it worked okay then, but does that really tell you whether that's going to reliably work? A one-off inspection on a regular basis. We're not going offshore just 1 year, it's every year and several times, but still it's kind of an MOT-based assessment. And then over time, our scope of work loses sight with the major accident hazard it was intended to verify in the first place. We kind of end up with a kind of checklist mentality. This is what we need to do, and we go through each one in turn. And each individual part is a good job, but the overall consideration of how that contributes to the major accident hazard management, we kind of forget about that perhaps along the way. So when we talk about next-gen verification, it's really to improve on some of those gaps. We want to create a higher value output from verification and move to this process safety type approach where it's the people, plant and process that we are taking into consideration. And that this should all align more with the intent of the major accident hazards and ties, which usually is a technique for mapping out what may impact upon a major accident hazard. And if we can keep these things all aligned and we can look at the different sources of information that helps us to understand the impact on those, then we start to see weak signals rather than just when a piece of equipment has already failed its performance standard. So we're looking for weak signals, we're looking for trends across one operator's own assets or perhaps the wider industry. And then if we can assess the various sources of information in a better way, then we can rebalance what we do when we go offshore. We don't need to continue to repeat tests that have already been done many times by the operators themselves. There are gaps that we're looking for, but we can focus on the gaps rather than just doing standard testing. So all of that comes about because there are new techniques available to us, of course. Analytics is a big part of everybody's daily discussions at the moment, but that applies to us too. How can we use our analytics techniques to inform us of where the risk really lies on an offshore asset? So we use data mining verification scheme, because at the moment the schemes that we have are very rigid. It says go offshore and test a certain number of fire detectors and a certain number of fire zones, and you're measured on whether you complete that or not. We need to make that a bit more high level, and it needs to be much less rigid. We need to use digital and remote capabilities, of course, which is becoming much more commonplace now because of COVID, and it's really accelerated the uptake of using remote capabilities. But that's only a part of what we're talking about here, and is really, in my view, a small part of the ability to analyse the risk comes from more the data than it does from remote techniques. But then we need to cooperate with the vendors. So sometimes when we go offshore, we want to test fairly major pieces of plant, which requires specialist support in order to test it. It's rare the occasions where we manage to match our visits at the same time as these specialists. You're having to increase the risk by testing equipment without the real specialists being there. So can we cooperate with them in a better way, understand their data better, and use that to also inform us? So we need to change how we be going offshore and kicking the tires and testing the equipment. We need to be taking in a new audit-based approach. We need to be using training our engineers with data techniques as well, and understanding how that shifts our focus of attention. And then this rebalance of effort. So I've got a couple of case studies on how we've been proceeding with this. There's a lot on this slide, which I apologise for, but this is to try and visualise ignition prevention. Almost every piece of electrical equipment that's outdoors on an offshore platform has to be protected with what they call EX protection. It means that it's explosion safe. If they have a gas release, that piece of electrical equipment is not going to provide a spark potential. So this there's thousands of pieces of equipment on our platform, and therefore thousands of inspections every year to check the integrity of this equipment. So this dashboard is intended to visualize their compliance with their own plan, and then to drill down on the defects, which will be found, they'll be found and they'll be repaired, or they'll have a repair plan in place. But this allows us to drill down on what the patterns of those defects are, which ones are really risky, which ones are showing the same mode of failure, which ones are in the same locations, so we can understand where the risk profile really looks. So do they comply with the strategy in the first place, and then from there, how are they managing their defects, and what does that overall defect trend tell us? This is a completely different way of approaching our scope of work compared to what we used to do, which is a fairly random sample when we go offshore of visual inspections and a bit of a review of the inspection reports, looking at a total number of 4,000 inspections compared to just a handful of inspection reports. So that paints a completely different picture than what these kind of dashboards are about. The second one is what we call Maintenance Miner. So we're taking an Excel download of all the maintenance or testing or inspection records that an operator will have in their system. So either Maximo or SAP is the most common systems that our offshore operators use. We take them in Excel and then we upload them, pass them through our web-based tool, which is Maintenance Miner. It has an algorithm which reads the descriptive text that the technician offshore has written, and it then basically verifies whether we agree that that's a pass or a fail as coded by the technician. It then allows our engineers to have a focused sample for his review that then will allow us again to trend information, and we're not just relying on the pass-fail code that the operator themselves has given it. There's an additional check that was correct, and that's automated, and it allows us to again drill down in different ways, looking at types of equipment or defect modes and locations, and look to see, okay, well, is there more in one location than there are in others? Are we having combined risks where the fire and the gas detectors are failing in the same place? Is that a location that we should go spend more time at when we go offshore? Understand the testing routines, and change our inspection from being, again, random to selected based on data, and perhaps change to an audit to say, well, okay, well, show us how you do the testing here. Show us what the results look like. How is that different to the location just next door? So those are the two case studies that I wanted to draw your attention to, kind of conscious of time. So this is the summary slide that we like to use with a bit of added information on where the limitations are and why we see the benefits of collaborating with the likes with our friends at Eigen. So the benefits, this is work we're already doing with operators that we work with in the verification world, and so these benefits are real and already being demonstrated with these operators. But we can reduce the amount of offshore time and the intrusive testing that we would normally do. We can reduce that. We are already changing the verification based on the risk profile. So maybe the data shows that actually there's very few failures in one particular type of equipment. Well, okay, let's not bother repeating that testing. Let's rather shift our attention to something else. The reports are much more detailed, but they're focused on weak signals now rather than waiting till something has already failed its performance. We're able now to give insights on maintenance and optimization. We're somewhat cautious in that area because we are a third-party independent verifier, and therefore the lines across which we shouldn't really cross. We can't tell an operator you should do less maintenance here, because when it goes wrong next week, then they blame the verifier. That's not correct and it's not appropriate. But we can offer them up the information that says, well, look, this is what we see with you compared to maybe your colleagues next door, and your fail rates are very, very comparable. Maybe you want to think about it. And then everything that we take input and output wise is much more aligned to the bow ties and the major accident hazards. However, the data cleansing and the analytics require a lot of work, and it's not necessarily the same the second time you get it, either for a different asset with the same operator, or especially when you take a new operator in. Just you've done a safety system analytics for one doesn't automatically mean it will transfer easily to the next client, because the shape and the size of the data and certainly the column headers and how they extract from Maximal will be different. So that manipulation takes a lot of work, and generally we're doing most of it in Excel. Maintenance Miner does a great job for us in helping us to categorize, but most of it's done later in Excel post-processing. So it definitely works, but it can certainly be more efficient, and there's a bit of manual processing after the fact again to look for these relationships between the barriers. So really good stuff. We're really proud of it, but there's certainly scope for improvement where we could get better tooling and focus on digitizing some of these manual processes that are difficult to do when you can't connect together the data in a good and easy way. At which point leads nicely onto what Joel's about to talk to you about. So thank you, Joel. You can take over from here. Thank you.
Thank you. So if you stop sharing, I can share. Okay. So I will now pick it up from what next-gen verification, connected next-gen verification can do for us and how it can accelerate the benefits with the use of technology. So the general challenge we generally face here at Eigen is that we have data in lots of different systems, and what people use to solve a problem, analyze a situation, such as the cases of verification, they generally use Excel, Microsoft tools, Word, PowerPoint. They make some analysis and calculations and data cleansing in Excel. And after that, generally they produce trends for a report that gets shared via Outlook, for example. And so people need to work on this data, but these are the tools that generally people use. That's the general challenge. In the case of the next-gen verification, as Jack was explaining, obviously, it's all based on data dumps from systems that go into Excel. There's a lot of cleansing, manipulation, understanding what each column means, maybe some calculations, and then some reports are produced with any tool, Power BI, PowerPoint, or a custom web app, and then results maybe are sent via email to the people that need them. And you see here at the top, it's got verification reports of different types, and I've taken a screenshot of the maintenance minor report as well, so you can illustrate. The data is also coming from these different systems at the bottom, which are functional systems that everybody needs. Of course, the limitations of the process, Jack already alluded to those. It's manually intensive for data cleansing and manipulation. It's also a discontinuous data stream. When he mentioned is an MOT process, you know, do it at certain points in time. So it's a piecemeal verification that only happens at certain points. And the reports are static. We cannot take them and analyze further. We cannot play with them further for further analysis. So those are limitations that are very, that can be overcome with technology. So how can we do connected next-gen verification? Well, the data is still in the systems, but Eigen Ingenuity as a tool is a layer that can connect to all these data sources. It's an online connection in which we can pull data in real time or at given points in time, every hour, every day, as appropriate. Ingenuity can automate the analysis of the data and can produce automatically the reports that may be required. So the advantages of the approach are that connection to the data is real time. The processing of the data can be automated to a large degree. I hope to explain that with an example, which means that verification operations can happen continuously. Reports are generated immediately, automated. They can be accessible online. They can be shared, commented on, and analyzed further. So with this process, we can take those great engineering verification ideas that have been, you know, been done for a long time and are very well understood. They can come to life in a different way. Obviously, the formal verification process that the regulators demand and for compliance that are required, obviously they will need to be done, but they can now be done based on an automated data stream. Okay. And this is, I'm going to illustrate this with an example. I think is possibly the best way to see what we can do and where technology can lead us. And this is something we're already doing for one of our customers. And it's the verification of blowdown events. So blowdown events is when a certain segment of the plant, illustrated here, is depressurized due to a shut-in event or another emergency event. So the blowdown segment is defined as that area of the plant which is completely shut off from other areas and that needs to be completely depressurized. Okay, so we have automated the process of verifying this through a Python script that is connected to the Eigen Unity platform. Now that Python script is triggered by alerts that are generated based on our blowdown valves being triggered. And then the script goes ahead and takes the timestamp of that event, identifies the segment, which is already within the asset model within Eigen Ingenuity. It queries the data model for the related pressure tag, gets the data from the process historian, analyzes the event for the pressure drop requirements that are required for compliance with the blowdown event, creates the result sets and also writes the outputs and actually creates a trend graphic URL that can be inspected. So from the front end, from the user interface, we've got a summary of all the blowdown events and showing the most recent blowdown for every event. And this list of segments comes directly from the data model in the digital twin that we hold inside Eigen Ingenuity, okay? So the system already knows about all these segments and it can display in this list, the list of all the latest blowdown events. When we click on one, we're gonna get the trend of the last blowdown event, okay? You can see there, and also the list of all the blowdown events that have occurred for that particular blowdown segment, okay? Moreover, as I said before, the system automatically checks, that script automatically checks the compliance of each of one of those blowdown events. And in this case, it's the marker for 50% less pressure than at the start. And also when the pressure has gone below 7 bar. So those two vertical lines you see here, those are the markers for those two events. And the system can automatically verify that, yes, okay, this blowdown event has passed the quality criteria for safety, okay? And immediately these reports are automatically generated, available for engineers to look at whenever they want. So moreover, it's not shown here, but each one of these trends that are automatically generated in these reports, there are functions inside Ingenuity where we can create new reports based on them that can be included in other pieces of reports that can be commented, shared, throughout the organization for further analysis on an event. Say, for example, that there's a blowdown event that there was problematic, there's something wrong with it, then that can be taken further automatically for further analysis and comments and resolution by the engineering team. So it's absolutely a step change above what we can do, taking you guys to the next level. So just briefly, I just wanted to highlight how we get into Eigen Ingenuity roadmap. It's quite simple. Eigen Ingenuity can be deployed to the customer's cloud environment or your on-premise servers as you wish. From there, we can connect securely to your data sources and provide secure user access to the users of the company. In terms of licensing, there's two approaches to quickly start. One is we can offer free trial license for up to 6 months, where you only pay for installation services, okay? And you get to try the solution for free. The other approach is to jump on the pay-as-you-go platform as a service license deal, in which a monthly payment is started from the beginning with no minimum commitment, and then we take care of installation, setup, support as part of that ongoing license payment. So our license deals are fully inclusive. We take care of everything, including your support and your upgrades. Obviously, with DNV, with the synergy, you get access to DNV's engineering excellence in the field and our digitalization experience of more than 15 years working in this area to maximize benefits. We have been serving leading independent European oil and gas companies for quite a while, and we welcome any interest. And for that, here are some emails you can contact us on, and we welcome any questions at this time.